The idea with trigonometric integrals is integrating a product with two trig functions. So it's usually sine and cosine or tangent and secant. And there's a couple of tricks to solving these as well, depending on odd and even powers. First, whenever you are approached with any integral problem or problems with integrals, you want to ask yourself, can you do a u substitution? And in this case, you can't really, well, at least not yet. Integration by parts? Well, no. So let's move on to trigonometric integrals. And it should be obviously leaping out at you when you see trigonometric functions as the integrand to an integral. So the first thing, or you're really wanting to make it, you really want to simplify this so that in the end you're basically going to be doing a u substitution. It may not be obvious at first, but we can manipulate this so that it could be more clear to do so. So the trick is whichever one is odd, you want to split it algebraically. In this case, we have cosine cubed of x. So let's say that this is, instead of cosine cubed, let's say that it's x cubed, right? So x cubed is also the same thing as x squared times x to the first. Remember, with the same basis, you add the exponents. 2 plus 1 is 3. So let's break cosine x up into cosine squared x times cosine of x. Okay, it means the same thing. 2 plus 1 is 3. And don't forget the sine to the 8th power x, the integral of, and dx. Now, let's see if we could do a u substitution. Well, recall that the derivative of sine of x equals cosine of x. So if we let u equal sine of x, then du equals cosine of x dx. Okay, and that's exactly what we have right here, cosine of x dx. So, and we have a sine to the 8th of x, which we could easily substitute in a u right there. But what about this cosine squared x? Well, we need to think of a Pythagorean identity. Recall that sine squared x plus cosine squared x equals 1. How could we get cosine squared x by itself? We'll just subtract sine of x, or sine squared of x, from both sides. And we substitute that in right here. Okay, so let's go ahead and do so. And I'm going to write sine to the 8th power of x like this. Sine of x to the 8th, like that. And then I'm going to make a substitution. Cosine squared x is the same as 1 minus sine of x squared, which is the same as sine squared x. And then cosine x dx becomes du. However, we're still in terms of x right here, so just to be consistent, I'm just going to put cosine of x dx. Okay, now I'm going to substitute. Okay, u equals sine of x. So every time I see sine of x, I'm going to substitute a u. So that's u to the 8th times the quantity 1 minus u squared. And then cosine x dx, we said was du. And then it's just simple algebra with the integrand. I'm just going to distribute. And then it's simple power rule right here for integrals. This equals, we're taking the integral of u to the 8th, that is 1/9 u to the 9th minus 1/11 u to the 11th plus c, because it's an indefinite integral. And now we substitute back in, and that equals 1/9 sine to the 9th x minus 1/11 sine to the 11th x plus c. That's a valid answer. It could also be written as sine to the 9th x over 9 minus sine to the 11th x over 11 plus c as well. Okay, these both are equivalent answers right here, and that's how you do it. And again, in the end, it just takes practice. While you're taking this class, if you want to be a mechanical engineer, a biochemist, whatever your major is, whatever's in your heart, just don't give up on what is in your heart and what your passions are. And thank you, and just have a great day.